In this video, we're going to talk about decision structures and Boolean logic in Python. Okay, so looking here to the left, we see the normal flow of our programs. We're going to have a statement setting a variable, doing a calculation, printing out whatever we're doing. Okay, it's called sequential. You start at the beginning, just go to the end. And that works for a lot of the things that we do, but there are going to be programs where we're going to want to not always execute every line. Okay. So think for the example we did with a flow chart where we checked to see if a number was even or odd. We basically did a mod 2 on that, or a modulo 2, and to see if there was a remainder or not. If there's no remainder, it's even. If there is a remainder, then it's odd. Okay. And we didn't really have a way in Python code to be able to handle that situation. So you're going to have a print number is even statement and a print number is odd statement, and you only want to execute one of those, not both. Okay. And we'd mentioned briefly about the diamond as a in a flowchart to show as a way to model these decisions. Okay. And I have that here on the right. Okay. So if you look at the flow of this, you're in some process wherever you're at in your program, and then you move into this Boolean expression. Okay, so let's talk about what a Boolean expression is. You'll see the word Boolean a lot. In fact, we talked with variable types. We have a Boolean data type, okay, or variable type. So there was a mathematician, English mathematician named George Boole, who came up with a lot of the foundational work on this kind of logical work, basically. Okay. So we call them Boolean. So a Boolean expression is simply an expression that evaluates to true or false. Okay. In English, it's like, is it warm out? Okay. Now we have to be a little more precise in programming. But basically, something that evaluates to a true or false is a Boolean expression. Okay. So we're going to put that Boolean expression to work here. So let's say we're coming down to our program and we're going to say, is the temperature greater than 70 degrees? Okay. So if this is yes, we're going to follow one or more statements. Okay. Then we can say it's warm out or whatever you want to do. Okay. One or more. Okay. If it's no, we're going to have a different series of steps. Okay. And in any case, and again, that can be one or more things there. And there doesn't always have to be a no. Sometimes you only have an if it's a yes. Okay. And in any case, we're going to come back at some point to the main flow. And I wonder if let me do this. Yeah, we sometimes that's going to get a little bit funky here, but see if I can move that to there. Nope, that just messed it up. Anyway, sometimes you'll see it in this way where there'll be a yes and a no coming out to the side. And then that's got the lines all fouled up, but you get the idea. Okay. So if we're going to create these Boolean expressions and put Boolean expressions and put them into our decision structures, okay, we're going to have to use the mathematical symbols for relational operators. So a relational operator is an operator that takes two operands, so it deals on two things, okay, a left and a right, and it's going to return true or false to see if a specific relationship exists between those two values. Okay. So let's switch over here to some code and we can see. So the different ones that we use typically, okay, when you think of this, okay, we use a greater than, okay, which we're just going to use the regular greater than symbol for that. Let me make sure that text box actually for that. Okay. So make a text box. Okay. So we're greater than. This uses the greater than symbol. Pretty straightforward. Okay. We're going to use a less than. Use the less than symbol. That's on our keyboard. No problem. Okay. We're going to go with a greater than or equal to. Well, then the normal symbol that we use in math isn't available. So we have to use a greater than and equal to together. So it's two characters for that. A less than or equal to. Same thing, less than or equal to. Can't be a space, and it has to be in that order. Okay. Now we get to the weird one. which we'd mentioned before when we were talking about variable assignments, okay? If we're testing a quality, okay, it's two equal signs, okay? So just to show up here, if I say X is equal to 5, okay, and run it, okay, it didn't do anything, right? That's just, that's an assignment, okay? Let's not do anything. So I can print X. And now that you see that X is equal to 5, okay? If I say X equal to 5, okay, I'm now asking the question, is X equal to 5? Okay, which is a different thing, okay? And if I were to print this, okay, it's going to give me true, which is weird. It's giving me true because it's the nature of Google Colab. And some of you, I think, ran into this when you were doing your turtles. Even though I deleted the line where X is equal to 5, I think X still has the value of 5. So let's do something else here. Let's say X is equal to 12. Okay. Now you see that this is false. Okay. Now if I would put this in here, it gives me an error. I can't do that. Okay. So again, 2 equals means equality, 1 equal means assignment. Okay. And luckily in Python, if you try to use this in your decision statements, it will give you an error. If you're in C++, the next language most of you will hit, it just always assumes that it's true. The assignment is true, which is a different problem. Okay. So then the last one we have that we haven't talked about yet. I don't know why this does such a weird thing of doing that. Anyway, okay. We have the not equal. Okay. And the not equal is just exclamation point, not equal. Okay. So examples, I could say something like, is A greater than B? Any of these. Okay. Again, that will return a value. Okay. Or a true or false every time. Okay. So that's the basic idea behind the relational expressions. Okay. And yeah, it's weird to me that doesn't equate. Oh, I guess I have to do that. So let me go ahead and do that in there. This way, keep this up there. Okay. Yeah, now we've got all that. Yeah, that's what I wanted. Okay. So how do we turn this into code? Okay. So we're going to use the if keyword here. And the basic idea is if our condition, okay, and by condition, we mean a Boolean expression. Okay. If Boolean expression, okay, colon. So we haven't talked about it before, but other languages, if you've ever programmed in C or C++ or JavaScript or whatever, a lot of those languages, or Java, they're going to use curly braces to enclose their structures. Okay. Python doesn't do that. Python uses a colon at the end of the line to start an expression. Okay. And then when you hit enter, note that it indents. Okay. So every line that's indented over is part of this if structure. Okay. If not, so if I put something here, print, let me put an actual Boolean expression. So let's start again. Let's going to set X equal to 10, let's say. Okay. So a Boolean expression could be if X is equal to 10. Let's see, I did it already. X equal, notice it gave me an error when I did that. If X equal to 10, we're going to print X is 10, whatever. Pretty exciting code. Okay. Now, if I put something else here, like Y is equal to 20, okay. As we're coming down, we assign the X the value of 10. We're doing a Boolean. We're saying if X is equal to 10, then do the following. Okay, so we're going to do the print, and we're going to do this line. Okay, if X is not, so if we put print Y down here, okay, if X is not 10, lost my cursor. If X is not 10 here, it's going to skip to the next line that is back out at the same level the if was. So this line will do that. Okay. So the advantage to this, especially as a beginning programmer, you can see very visually where your control structures begin and end. Okay. In other languages, it lets you do with the brackets, you can do the spacing however you want. Python enforces that. Okay. Notice if I put an extra space in there, Python blows up, won't run. Okay. It gives you a spacing error. So the spaces are very important. So in this case, this doesn't make a lot of sense because if X is not equal to 10, Y never gets a value. That would make a lot more sense. Okay. So that's our basic structures there. Okay. So we have other, and we can do more than one thing there. Okay. We could do another print statement, or X is equal to, X divided by 5, whatever you want to do. Okay. As many statements as you want, as long as you're indented over. Okay. So sometimes you're going to have two options. Okay. Like our decision tree. What happens if yes? What happens if no? In this case, if there's no, nothing special happens. Okay. So this line is always executed first. This line is always executed second. And if it's true, this line and this line are executed, and then this line. Okay, down to the Y. Okay. If this is false, it's going to skip all this and go directly to here, and both get printed here. Okay. But sometimes we want to do something if there are two different options here. Okay. So let's go ahead and go back to our even odd number. Okay. So let's say we're going to have the user input a number. So we're going to say num is equal to an int, an input, enter a number. Okay. Some of you have asked about error checking, and we're not. If they type in letters, it's going to throw an error. We're not to errors yet. We're just going to assume our users are good users now. Okay. I can now do an if on this. If num mod 2, so I'm going to take the number they've entered, I'm going to divide it by 2 and look at the remainder. That's what the modulo operator does. Okay. So if it's even, this should equal 0. Again, 2 equals. Okay. I can print your number, or I just print number. I can print num is even. Okay. I then have to space back over to do an else. Okay, these are 2 options. Else, print num is odd. I mix the double and single quotes, which is probably not the best stylistically, but it should be okay. Okay. And now I can print that this line executes in all cases. Okay. I'll put a space there just to see. Okay. So when I run this, I'm going to enter a number. If the number is even, it should print this and then print that, the last line. If the number is odd, it should print that it's odd and then print that. Okay. All based on the spacing. Okay. Run it, enter a number. Let's enter 14. 14 is even. This line executes in all cases. Okay. Run it again. Let's enter 99. 99 is odd. This line executes in all cases. Okay. If we're testing this, we want to see, what if we enter a negative number? Negative 23. Negative 23 is odd. That's okay. Okay. What if we enter a 0? 0 is even. Okay. There's some debate whether 0 is even or odd or neither, but for our purposes here, this is going to be okay. Okay. Note that if I simply indent this over, and run it with an even number, that line does not print. Okay, that line only prints if I run it with an odd number. Okay, so that would be incorrect. Okay, so we're going to use this in nearly all of our programs. Okay, it really is an important thing. Okay, so another thing that we can do here is that we can compare strings. Okay, so we can do something like name is equal to int, enter your name. Okay, then I can say something like if name is equal to Bob, I can print, again, equals wrong, but notice it puts a squiggle there. I can print hello, Bob. Anyone else? Print you are not Bob. Okay. And then if I had another line, print and or whatever down here, that's going to happen in either case. Okay. So I run the program. It's got a problem. What problem does it have? Oh, I said int. Input's what I want. Good Lord, it's early. Okay. Enter the name. Let's enter the name of Bob. Hello, Bob. Then we get the end. Okay. Run it again. Enter the name Alice. Nope, we're not Bob. Okay. Note that these comparisons are case sensitive. Okay. Bob is not Bob, lowercase b. Okay. So it makes a difference. Okay. The other thing kind of weird with strings when we're comparing them. Okay. We have string. Well, let's do a simple one here. I can just say is hello greater than hello. Okay. Turns out that is false. Well, how did it figure that out? Okay. It figures it out by looking at letter by letter. Okay. And it's all based on the ASCII codes. And the book talks about the ASCII code. An ASCII code is just a way to represent letters with numbers. Okay. So it turns out that the capital letters have a lower number than the small letters. Okay. So in this case, it's false that hello is greater than hello. Okay. Okay, so let's do some actual examples here. Let's say we're going to have a program. It's going to be and again, in my examples, I often don't put in a program block. Every program needs a program block. Okay. Let's see a sales target. Okay. So we're going to start by entering the salesman's name, the salesperson's name, input, name. Okay. And then we're going to enter the sales for that person is equal to, let's do an int in round numbers. Int input, enter the sales for salesperson, comma, go ahead and put a, oh, actually, I'm not sure I can do all that in the input statement. This is what I'm saying, enter the sales this way. That's probably the easier way to do that. Okay. Enter the sales there with a colon. Okay. And let's go ahead and use, we talked about this in the last chapter, named constants. Okay. So I'm going to say target is equal to 5,000. Okay. So again, in most languages, So it's kind of like programming lore that if you see something in all capitals, it should be a constant that should change in the execution of your program. Many languages enforce that. C++ enforces that with a constant keyword. In Python, you just have to respect it and not do that. Okay. So we now have our target there. Okay. So I've entered the salesperson's name. I've entered their sales. Okay. For the month, for the whatever. Okay. So I can now do an if. I can say if the sales that the person did is greater than or equal to the target. Okay. Now I can say that salesperson, comma, met the sales goal for the month, whatever it is. And you probably would actually want to enter what month it was, all that stuff, but we're gonna, well, let's go ahead and do it. Let's go ahead and let's be correct. So let's say month is equal to input, enter the month. Okay. Yeah, I still have a problem. The imp, I keep doing int instead of input. I'm losing my mind. Yeah, I think you can't put complicated strings with commas inside of an input. I think that's the issue. So we'll leave it like that for now. Okay. But in a print statement, you can. So I can say we can for comma month. That should be okay. Okay. Got an else. Print. Basically the same thing. So I can cut paste. Salesperson did not meet the sales goal for the month. Okay. And I often like to put some spaces in here just to kind of see what's going on a little bit. Makes it even more visual. Okay. So if this program, if we've got it all right, we're going to set the target to 5,000. We're going to have them input the month. We're going to, again, we're doing no checking. We're going to have them input the salesperson name and then the sales for that month. And then if the sales are greater than or equal to the target, then say they met the sales goal. If not, they didn't. Okay. One thing that's important to remember when we're doing greater than and equal, we have to make sure that the equal gets counted. Okay. Sometimes we'll do, if it's greater than this, do that. If it's less than that, do that. We don't deal with what if it's equal. So we'll have to keep that in mind. And you have to figure out in this case, in every case, does equal mean success or not success? Depends on the program. In this case, if they have a sales of exactly 5,000, then they've met the goal. So we have to put the equal with the if. If we didn't, then and we'll take a look at that, a sale of 5,000 would equal not being their goal, which is incorrect. Okay. Let's run this, see what we get. Okay. So enter the month of July, just because it's fewer characters. It's going to be our friend Bob. Let's say they sell exactly 5,000. Okay. Why is it giving me another input? That's really weird. It doesn't like this. If sales, that was supposed to be an int. There's two people in the room, so you could be yelling at me. Okay, let's try it again now. That makes more sense. Okay, we got July. We've got Bob. 5,000. Okay, Bob met the sales goal for July. Okay, so again, to show that other point, if I take that off and run it, it's July. It's Bob. And if you enter 5,000, we see that Bob did not meet the sales goals for July, and that's not correct. Okay. So I want to make sure that I put the equal there. Okay. Other thing that's probably worth doing here is if you put in a tab character. think that makes the program look a little better. When you're not pressed for time and you have a chance, it's worth making your programs look a little better. So let's see if this works. Okay. In the month of July, Bob, let's say do 7,000. Okay. So that tabs that over. It's a little easier to read. Okay. Let's run it again with 3,000. Oh, that was wrong. Yeah, sometimes you got to write it out. It'll give me a value error. The month is July. Salesperson's name is Bob. 3,000. There we go. Okay. And now it says that Bob did not meet the sales goal for July. Okay. So that's a mostly fully formed program. Again, I would need my comment block for that one. Okay. And most of you are doing fine on the problem sets, but if this were one program and I gave you another program, we're going to do one on passwords, like a password example, not a real one that you should use, but a simple idea. Okay. Then you would create a new code block for the second program. Okay. Again, you would have all the normal stuff that we have here. There's a marker. You have the name, you have the date. It's August 26th, 2023. Okay. And you can have some notes. Whatever. This is going to be a fake password program. Do not really use. Whatever you've got. Okay. At a minimum, you want to let me know which program it is. Sometimes I have to read your code to try to figure out. So the note should at least say what the program does. If you don't, give it a name, such as, you could call this, if you like, you could say something like program 2. That was program 1, is program 2. Something like that, just so I know when I'm grading it, what's going on. Okay. So for this one, we want to ask the user for a password, and we want to see if they've entered the password correctly. Okay, so we're going to be comparing some strings. So note that the problem with this program, why you would really not want to use it, is that we're just going to store the password just in plain text. Everybody can see this file. It wouldn't be safe at all. Okay. And since we're being bad, we're just going to call the password, which is another bad idea. Okay. So the first thing we have to do, we have to get the guess from the user. Okay, so the guess is going to be equal to input, enter your password. Okay, they enter it, then we can simply do if guess is equal to password, then we're going to print password correct. Else, we're going to print password incorrect. Okay, that's all we're going to do. Okay. Again, there's more things that we could do with that. Okay. But this is just at a basic level. Okay. So I'm going to enter it, enter your password. If I type in gibberish, password's incorrect. Okay. If I type in password, it is correct. Okay. So, that's all. I think it's all relatively straightforward once you get the idea of the if. Okay. One thing that we can do, we've had a problem with our calculations, and I'm just going to go ahead and make a new one here without all this. So we want to avoid a division by 0 error. Okay. So I could do something like num1 is equal to int input enter a number, copy that again. Maybe I'm going to copy it again. Okay. Num2 of enter another number. Okay. And then let's say we're going to print or numbers multiplied are, comma, and then num1 times num2. Okay. This should work, and it should evaluate. Let's see, make sure it works. We enter a 3 and enter a 4. It does. So, we're doing the math inside of our print statement, and that's fine, not a problem. Okay. And then let's say I want to do the same thing for division. Okay. Copy that. This is a very forced example, but you get the idea. Okay. So I'll run this. Okay. I do a 3 and a 4. We get a 12, we get a 0.75. Life's good. Okay. So we know this is not good if I enter a 3 and a 0. Okay. It blows up, gives me a 0 division error. Okay. So using the control structures, I can fix this. I can say if num2 does not equal 0. Okay. Notice it now gives me an error because I need to have something over there. There needs to be at least one line there. Okay. And now do an else. Say print. Second number is 0. So you can't divide whatever you want to say. Okay, so now if I run this, I do a 3, I do a 4, works just like it did before. Run it again with a 3 and a 0, and now it says second number is 0, so you can't divide by 0. Okay, so that's the basics of the if and the if else statements. Okay, so in the next video, we're going to expand that and have more options that we can take. But for now, that should get us started. If you have questions, make sure that you let me know.